It was not by chance that Srinivasa Varadhan's study was the science of probability.
There has always been a tradition in India of learning mathematics.
This tradition fostered sweeping theories in the math field, from the concept of zero to the decimal system to number theory.
There are many problems in the world, and in order to understand and solve them, you have to formulate them in terms of mathematics. We face a lot of uncertainties. Things are not determined perfectly, so we make statements. The chances or the probability of something happening, 1 means it's sure to happen, 0 means it's never going to happen, and you say it's 50%. That's how probability comes into play. But sometimes things are so rare that their probability is very tiny. But then you can't always ignore it, because the consequence of that happening could be very catastrophic, in which case you want to guard against very small chances too.
It was 1966 when Varadhan introduced a unified theory for large deviations, that is, rare events. In essence, helping us to estimate the small instances so we might be prepared for the catastrophic.
I've done many things, and I always keep coming back to large deviations. There are many problems which are very different. They don't look like they have anything to do with large deviation, but they somehow end up having something to do with it.
Varadhan has spent a life and career at NYU's current Institute of Mathematical Sciences, with an uncanny ability to glide between logic and intuition.
The way I see it is, if you have a problem in biology, you have to understand chemistry. And if you want to understand why things happen in chemistry, you have to know physics. And if you have to understand why things are the way they are in physics, you have to know mathematics.